Welcome to tonight's video on higher order derivatives. In today's video, we're going to talk about how to find second and third derivatives of a function. So one of the things to understand, and it's in this here, is that when you, because the derivative is a rate of change, so the derivative of the derivative is the rate of change of the rate of change. And an example that we've done so far is the derivative of the velocity function is the acceleration. And remember, acceleration is the second derivative of the position. So one of the things it asks is, it says, if f of x equals x to the seventh, find the fourth derivative of x. Well, using the power rule, the first derivative would be 7x to the sixth. The second derivative would be 42x to the fifth. The third derivative would be 210x to the fourth. And then the fourth derivative would be 840x to the third. Notice it says which derivative will result in 0. Well, if we kept going, the fifth derivative would be something x squared. The sixth derivative would be something x. The seventh derivative would be a constant, right? So the eighth derivative would equal 0. So notice the pattern is that whatever the exponent is, it's one more than the exponent. So if you're trying to find the fourth derivative and the highest power is to the third, then you know that the fourth derivative is going to equal 0 without even having to do the work. Yes. All right. So the third derivative, if f of x equals 1 over x, well, remember, change that to x to the negative first. That is not the derivative, that is just the function. The first derivative of that would be negative 1 x to the negative second. The second derivative would be 2x to the negative third. And the third derivative would be negative 6x to the negative fourth. But remember, we can't have negative exponents, so it'd be negative 6 over x to the fourth. Final answer. All right, the fourth derivative of sine x. Well, the first derivative is cosine x. The second derivative is negative sine x. The third derivative is negative cosine x. And the fourth derivative, remember the derivative of negative sine, so you have negative of negative sine, so it's positive sine x. The second derivative of tangent, well, the first derivative of tangent is secant squared. And remember to take the second derivative of that. This is the same as saying secant x squared. So the u is the secant x. U prime is secant x tangent x. So this would be a chain rule. So f prime of u would be u squared. So the double derivative, or the second derivative, would be 2u times u prime. So if you put the x back for the second derivative, it would be 2 secant x times secant x tangent x. Well, you can multiply the like terms, so it's 2 secant squared tangent x. And then to make it simpler, we'll change it to sine and cosine. So this is 2 times 1 over cosine squared times sine over cosine. So when you multiply, it's 2 sine x over cosine to the third. That is the second derivative. All right, next one, you have, to find the first derivative, you have a quotient rule. So we'll say, we'll let h of x equal x squared plus 3x. So h prime would be 2x plus 3. G of x is the denominator, that's x minus 4. G prime is 1. So when you do the quotient rule, it's going to be x minus 4 times 2x plus 3 minus x squared plus 3x times 1, so just x squared plus 3x, all over x minus 4 squared. So when you FOIL here, you get 2x squared minus 8x plus 3x minus 5x minus 12, and then minus x squared minus 3x all over x minus 4 squared. So combine like terms in the numerator, you get x squared minus 8x minus 12 over x minus 4 squared. So that's the first derivative. Now for the second derivative, you have to do another quotient rule. H of x is equal to x squared minus 8x minus 12. H prime is equal to 2x minus 8. G of x is equal to x minus 4 squared. G prime, you have to do a chain rule. So u would equal x minus 4, u prime would equal 1. So basically it's 2 times x minus 4 times 1, but that doesn't do anything. So when you do the quotient rule, you have x minus 4 squared times 2x minus 8 minus 2 times x minus 4 times x squared minus 8x minus 12 all over x minus 4 squared squared. So when we simplify here, first of all, there's an x minus 4. All right, so notice they have a common factor. That common factor in the numerator is x minus 4. So we will take that out of the numerator. And then what's left, so you have 2x minus 8 times x minus 4 minus, and then you have 2 times x squared minus 8x minus 12 all over x minus 4 to the fourth. So notice here, this will cancel, and that becomes to the third, so it's x minus 4 to the third. Then here, when you FOIL, you have 2x squared minus 8x, and 8x is minus 16x plus 32 minus, and then distributing the negative as well as the 2 gives you negative 2x squared plus 16x minus plus 24. So when you cancel, notice those cancel, you get 56 over x minus 4 to the third. Final answer. All right, so the next one, the double derivative, second derivative of x sine x. So this is a product rule. So notice one function, we'll call it h of x, is x, so the derivative is just 1. The other function is sine x. The derivative of sine x is cosine x. So the product rule for the first derivative says that you say x cosine x. plus sine x. So now taking the second derivative, you once again have a product rule here. So h of x equals x. H prime is 1. Now the second function is cosine x. So the derivative is negative sine x. So you have negative x sine x plus cosine x. And then you take the derivative of sine, and that is another cosine. So when you combine like terms, you have negative x sine x plus 2 cosine x. Final answer. All right, so that concludes our video on the higher order derivatives. There is a WebAssign to complete, and then you can also start working on the cumulative. All right, have a good rest of your day.